Yeah, we are coming close to the end of this year's monsoon. So as of today, I couldn't update it. 20th September, the rainfall is 671 millimeters, which is 7% below normal. So it's slowly approaching what the prediction of 6% below normal. So it looks like going in the direction. And if you look at the analysis of the last based on 40-day MGO mode, what I wanted to see here is very interesting, sharp difference between here and here. End of August and September, the velocity potential anomaly sharply changes from here to here. Okay? And then we are continuing on this phase now all the way back. So that's something unusual happened, not clear what happened. End of August, beginning of September, there was a change in circulation. Now, so you can see that we had a delayed start due to cyclone, very nice thing in June, then July, and then August was very bad. September recovered. It looks like, as you'll see in the broadcast next 10 days, will continue to be above normal, okay? Which is very unusual. Remember that in 2019, we had a very unusual event, but that was the La Nina connected partly, and of course, IOD. This year, there's an IOD linked to El Nino. Okay? So it's a very different kind of phenomena. And so this is developing. What I was showing last few weeks is getting bigger and bigger. Okay? But how this affects the monsoon is not clear to me. One has to say this, why it affects the monsoon is very clear. Very warm anomaly, more water vapor comes in India. This one, what is the mechanism by which this cooling here and the change in wind along the equator, how it affects the monsoon, I have not seen a credible explanation. Now, September forecast meant IMD said it will be plus or minus 9%. I think they'll come out right. It will be positive, probably a few percent. We'll see next week what the exact amount is. Then you compare last week's prediction. I'm quite impressed. This is 7th to 13th. This is 8 to 14, one day difference. They correctly got the high rainfall here, low rainfall here. Of course, here very high deficit. But the forecast was below normal. Otherwise, I would say they have done quite well, even spatial pattern wise. Okay. So the next 10 days, which is the end of the monsoon, 1 more days, end of the monsoon, consistently 50% above, which is really remarkable for end of September in an El Nino year. Remember, I showed you scatter plot of El Nino and Nino 3.4. It always showed negative. This year is not so. Why? Not clear. Why this year El Nino had no impact in September, no impact in July, huge impact in August. So this is the mystery of this year's monsoon. Now let's summarize it. Up to today, 60 millimeters, according to whatever forecast they're given, somewhere between 60 to 70 millimeters, add these two, at 8:30 come right here. Okay. So most probably they'll get into 95% of the normal, exactly in the lower end of the IMD forecast. So the point is, I think that is by luck. We have such an extreme August and equally extreme September. The fact that they got it right, we're not clear for what is got it right. Now let's compare others. SkyMet also said 95%. Okay. So SkyMet also is right. Okay. I'll go further. This is forecast given by Ravi. Okay. Ravi engineer, and based on machine learning. Okay. And he has used sea level pressure, sea surface temperature, zonal wind, and so on, and combination thereof. All of them, some of them are showing 90 to 95, one of them showing 98. But if you take an average of all, it's 95. Again, very close to. So everybody is getting it right, but we don't know why. Okay. Actually, machine learning, I'm impressed. As a matter of fact, Ravi gave a forecast in 2016. You remember, right? And he was right. Now, have you forecasting every year?
In between, yes. Till 2019, we got a near normal. We didn't get the excess.
Okay.
But we got it around 100 or 102%. And between years, we have, some of the years we have done, but after 2020, because my postdoc there.
Okay.
So I didn't have anybody to run it. But now I'm training a student.
So 2016, I'll show you. 2016, he got it right. This was a La Nina year, which everyone thought was well above normal. And IMD, out of sections of 2015, made a bold prediction. With this, IMD made this. Climate also said this. The truth was here, and Ravi's deep learning model got it right. Okay. So he has got it right on 2 occasions, which were very unusual. But my problem is, can you predict a phenomenon we do not understand? So I repeat what I said 7 years ago. Ultimately, this may win over this. We do not understand the phenomena, but Tata Stan may actually predict it, which bothers me as an academic, that it can happen because there are a lot of data and you use data very smartly, like Ravi is doing, using some physics. You might do better than other models. But to me, if you do not understand how the model got that answer, there's a potential for a major failure in the future. Because we are not sure that all the input we are putting into machine learning model has all the modes of variability. So if you depend too much on machine learning, at 1 year it will completely go wrong. That's why it's so important to understand why it got it that way. Now let me just go back to ECMWF forecast, which I'm looking at only this year, not in last few years. This was the forecast for June, July, August based on May initial conditions. Okay. Now this is not good because it's predicting very high rainfall for Bay of Bengal and Western Ghats. No signal over India. Some negative signal around 30 knot, and Indonesia negative. That's not surprising, and pretty high rainfall. Now I would like to compare that with rainfall, but we don't have high quality real-time rainfall data. So I'm comparing to OLR. OLR is measured and available easily. So OLR and rainfall forecast do not agree. OLR shows clearly, as expected, that June, July, August, there is OLR positive anomaly right above the equator, all the way from here to here, which ECMW is not capturing. Okay, and it is capturing this portion somewhat, but it's not capturing. Yeah, this is not surprising. During El Nino year, more rainfall occurring along the equator and off equator, that is this time. That's okay. But this one is not capturing. Okay. But let me again go through what I said last time, because I made some mistakes. I want to re-look at it. This is the All India rainfall forecast by ECMWF. Okay. And I just repeat what I said last time with some corrections to that. So first main prediction is that June will be below normal, so right. July above normal, right. August normal, not right. September below normal, not right. So in May, we got 2 months right, 2 months wrong. Okay, remember that. Next, we go to June. June, they said June is below normal, correct. July, slightly above normal, not very good, but it's okay, the design is okay. August, well above normal, completely wrong. September, below normal, totally wrong. So again, they got 2 right and 2 wrong. Okay. But remember, it's changing. At least June is consistent, but you'll see August what will happen. Now I come to 1st July. Okay. 1st July, forecast for July is above normal, correct? Forecast August is normal, slightly wrong, but I think this is be wrong. September is well below normal, wrong. Okay. So see how it's changing every month, the forecast is changing. Now we come to August, and suddenly it gets to August country. So this clear to me shows me this is a circulation driven change that occurred in August, because they couldn't predict in July. The August was they got the right input into the model in the initial data, which enabled them to get the August right. But September is still wrong. Now let's look at 1st September. They got it right. That again is puzzling, right? In 1 month, forecast changes sign. Okay. So both is point to the fact that both September and August rainfall was heavily dependent on circulation change that occurred around the beginning of that month, which they could not capture, they could not simulate with data 1 month earlier. Okay. So this is very interesting result. And I want you to look at the website. There are lots of things that I couldn't look at all of them. This is the prediction of IoT. Okay. So what I'm surprised by is that according to them, July IoT was around 1, and it increased to 2 in August and 2.4 in September, and then slowly decreasing. Okay. Now the question is, if you are going to claim that IoT is the one which caused ISMR to be normal this year or close to normal, then you have to ask how come IOD played no role in July, no role in August, but played a role in September? That is the puzzle we have to solve. Okay. IOD already turned positive by July, and it improved in August, had no impact on August rainfall, but September suddenly it has an impact. Now, I don't have an answer. You can think about that issue. This is a prediction CFS V2 say. CFS V2 also says IOD will rapidly increase from July and hit a peak around September, October, and then come down. Okay. So CFS V2 and ESMW will agree on how the IOD develops. Now, August break is a very important puzzle this year, and Arindam gave me this plot, which is from ERA5, because I originally looked at answer pre-analysis. It gave an answer that there was no anomaly over India, which is not possible. When you have such a huge break and rainfall well below normal, whatever has to be lowered. Something wrong with answer, we all know that. So Arindam helped me to get the ERA data, and that is very interesting. This side, okay. Actually, Northeast, over normal rainfall, even August. So this is an interesting evidence, which to me may hint the fact that the August drought was driven by something coming from that side. Okay. Now this has been argued for a long time. What triggers the break? So one hypothesis is that dry air from Afghanistan and north of that coming to India, not at the low level because there are Himalayas mountain there, so it can come. They can come above 7 millibar. Okay, come right through, or they can come coast. They can come around like this also. So the idea is that moist air comes from Arabian Sea at the lower level. Dry air comes from Afghanistan and other places at a higher level, and because of that, deep convection is not possible. So higher levels are dry, lower levels are moist, but the parcel cannot go all the way up. That is the hypothesis. Very interesting one, but I'm not seeing a true proof of that yet.
Sir,
and yes.
Sir, if you just look at the dry phase of MDO, you don't need to something extraordinary for these kinds of signals, because in the dry phase of MDO, it will be anticyclonic over that region.
So August?
Sorry.
In which month? August or September?
Yeah, August break. So in future break condition, when I mean I'm talking about the canonical thing.
Okay.
When you have a dry phase of MDO, the circulation will have the anticyclonic circulation that can bring the dry air from the region.
As far as I know, MDO in August was not.
Yeah, but the kind of wind anomalies have shown in some previous monsoon campaign.
In those years, MDO was strong. This year was very unusual, except for September, when MDO can. There is no signal in MDO.
No, we have shown some anomalies.
Yeah.
Wind anomalies. So it looks like the dry phase of it looks like from August the dry phase came, and then in September the next wet phase came.
Yeah, but you tell me if MDO is not above 1, not working number, how it is affecting not in that part? Look at it. So the argument that a lot of people are about long break. Remember, there is not a few days break; it's a long break. Okay, long break argument is something happening in mid latitude is coming here. Okay, and as an alternative hypothesis also coming from southern hemisphere by Rodwell. Southern hemisphere bothers me because southern hemisphere dry air cannot come to India. It will come to Arabian Sea. It will become moisture. I don't know how. But Rodwell has a hypothesis on that. Now, this is a nice picture from Ian Kashmuti's paper published about 13 years ago, in which he tracks, all of you can do it now with better data of reanalysis. He tracks the 850 millibar wind coming from Arabian Sea and the 700 millibar wind coming from exactly where I said it's coming. Okay. And the argument is this is what causes the break. Conditions, although there's moisture in the bottom layer, there's no moisture above the bottom layer, so clouds don't go deep enough. An interesting hypothesis. But the only problem is this particular graph in Kashmuti's paper is on 16 July, which I don't like. It's the middle of the break. Everything has happened. You cannot prove A causes B, B causes A, because the break started around the first week of July, peaked around 16th, and then. So my point is that if you want to demonstrate that dry air